Good morning, guys. I trust you are doing well. So, today I want us to talk about electron arrangement and the periodic table. You guys have already memorized all the periodic tables elements and you are already comfortable with each of them. So, if you did not memorize them all yet, so I encourage you to continue working on it following the links I have posted for you all these 3 days. So today I want us to focus on the electron arrangement in the periodic table. Okay, so there are specific elements you need to consider on the periodic table because it will guide you to already know some specific elements. For example, the periodic table will guide you already to know just by looking at one element to already know how many electrons that atom will have in the outer shell. That's the first thing. And the second thing, it will also guide you to already know what are the total shells that atom will have. Okay, so just by looking at the periodic table. So now I want you to keep the specific elements in your mind. Firstly, we say elements in the same group have the same number of electrons in the outer shell. So elements in the same group, elements of the same group have the same will all have the same number of electrons in the outer shell. What does it mean? Let's take one element of the first group. Okay, let's for example take sodium. Okay, sodium has as atomic number 11. Okay, sodium has 11. So we say all the elements of the first period will all have the same amount of electron in the outer shell. Okay, so when we have this, let's find the electronic structure of this. Okay, it's 11. So we already know that the first shell, the inner one, will have only two electrons. Sorry, so I put already 2. I have 9 left. Okay, so I continue. 9, the second one can have 8, so I put directly 8. And the third one will have, because 8 plus 2 gives me 10, and plus 1, so I have only 1 left. That's the one I put here. Okay, so the outer shell here is as 1 electron only. Okay, so let's take another one of the first group. Another one I'm taking now, potassium. Okay, potassium, the symbol is K, and the atomic number for potassium is 19, as you can see, guys, 19. So let's work out the electronic structure. Okay, so the first shell always has 2, the second have 8, so that makes 10. I can add again 8. The third one has also 8. You already know how to do the electronic structure. We learned already about it. And that makes 10, 18, and I have 1 left. That makes 1. So you see also here, the outer shell also have only 1 electron. So you already can see both of them have only 1 electron on the outer shell. Okay, so I can take any number of the first group, any element of the first group, it will still give me at the outer layer, outer shell, 1 as the last electron. Okay, so keep that in your mind. All the elements of the same group will all have the same number of electron in the outer shell. I can take, for example, again group, let me take group 5. Okay, group 5, I take carbon. Group 5, I take carbon here. Let me take carbon. And the atomic number for carbon here is 6. I put 6 there. So the electronic structure of carbon will be 2, and 4 is left, so I put directly 4. Okay, this is what I get. It's group 4. Now I take another element of group 4. I take silicon. Sorry. So silicon has atomic number of 14. Here is 14. So I work out the electronic structure very quickly. As you guys can see directly, what am I going to have? The first shell always have 2. The second one will have 8. That makes 10. I have 4 left, so the last one will be 4. Okay, so you directly see that the two of them has the same number of electron in the outer layer. So that's confirm what I said before, that the element of the same group will all have the same number of electron on the outer layer. Okay, good. So let's move on. Now the second thing I want you guys to keep in your mind is, for the main group elements, the number of group is the number of electron in the outer shell. What does it mean? What are the main group elements? It's group 1, group 2, group 3, group 4, group 5, group 6, group 7, and group 8 only. So you take group 1 to group 8 and you forget about the transition element. Don't forget, you don't consider the transition element, only group 1 to group 8. Okay, so for these groups, the number of the group is the number of the electron in the outer shell. What does it mean? I consider first these two ones. These two atoms belongs to group 1. Okay, so we say the number of the group will be the number of the electron in the outer shell. So this two one belongs to group 1. So that simply means the number of the group, that is 1, will be the number of electron we'll find in the last shell. Okay, so group 1 we have 1 1 in the outer shell. Okay, so this belongs to group 4. So if I take group 4, the number of the group is 4. So I should find at in the outer layer, outer shell, sorry, the number of electrons should be 4. So I check here, it's 4. Okay, if I take, for example, an atom of group, let's say group 7. Okay, I take chlorine, for example, that has an atomic number of 17. Let's work out the electronic structure. The electronic structure here is, the first layer will always have 2, the second one 8, that makes already 10. So when I have 10, I have 17 left, so the last one will have 7. So I say it's group 7. Okay, group 7, it's chlorine, and for chlorine the number of the group is 7, so the outer layer also have 7 electron. Okay, so I can now draw it so you can understand. I take this is the nucleus, and the first shell is right there. I put my 2 first electron there, 1 and 2. I move on, I work out the second. With the second, I put 1 2 3 4 5 6 7 and 8. That makes a total already of 10 electrons. So 17 minus 10, I have 7 left. So this is the 7 I should put on the last layer for me to have a total of 17 electrons orbiting the nucleus of this atom. So 4 already, 5, 6, and 7. So when I count, I have 2, 4, 6, 7. So 7 electrons in the last shell, the outer shell, that is this one. Okay, so the number of the group is group 7, and the number of electron I found also in the outer shell is 7 electrons. This is the thing. Okay, so whatever number I will take from group 1 to group 8, forgetting the transition element, the number of the group will always be the number of electrons I will find in the outer shell of that atom. Is that clear so far? Good. Let's move on. Okay, so you already know that elements of the same group have the same number of electrons in the outer shell. That's what we've demonstrated here. And secondly, you guys know already that the main group element, for the main group element, the number of group is the number of electron we find in the outer shell. This is what we demonstrate here. Now let's talk about the third one. The third element I want you guys to also have in your mind, that the periods also have numbers. Okay, we have period 1, period 2, period 3, period 4, and up to period 7. Okay, so this number of period shows us how many shells of electron the atom has. What does it mean? So if I consider period 1, okay, now let's say period 3. So for period 3 the number is 3. So that simply means all the atoms, all the elements I'll find in on period 3 will all have 3 shells, okay. Let's take a very simple example. Period 3, the first element I'm considering now here is magnesium. Okay, it's in your book. I take magnesium, page 56. Magnesium, it's period 3. What is the atomic number of magnesium, you guys? It's 12. So that simply means for magnesium I should have, as it belongs to group period 3, so I should have 3 shells. Let's go. So first layer always have 2 electrons. The second one will have 8. So here already 10 left. So I put 8. So it's 2 left. So I put again 2. So how many shells do I have? 1, 2, and 3 shells. You see? So 3 shells, it's period 3. I move on again. I take another one that belongs to that group. I take argon. Okay, let's take argon. Argon has an atomic number of 18. Yeah, argon, it's AR. I'm sorry, argon, it's AR, and the atomic number is 18. So let's go. The electronic structure of argon is, the first one is 2. The second shell will have 8 as always. That makes 10. So I have 8 more left. So I put again 8. So that makes 10 and 18. Okay, how many shells do I have? 1, 2, 3. So 3 shells because it belongs to period 3. Okay, so when I consider now, let's check for the other properties I mentioned above. Okay, so magnesium belongs to which group? Magnesium belongs to group 2. Okay, so the number of group is 2. So the outer shell should have how many electrons? 2. Let's check. It's 2. Correct, right? Aha, you see. So this is verifying the property I've mentioned before. Okay, and we say the same number of electrons in the outer shell. So it's group 2, so I have 2. And the number of shell, because it's period 3, so I have 3 shells. Okay, so these are the 3 elements I wanted to mention. So I hope this video has been helpful for you. So I'm going to ask you to go and download the worksheet I post on Class Story, and you guys will work out some exercises I've posted there for you. So if you have any question, don't hesitate to call me or to send me a message. I'll be very happy to give you more details or more explanation if you need it. Okay, so thanks for watching, and I'll see you next time for our next video. Bye.